Hi folks, this is Steve here doing another YouTube video for those of us that aren't power users of FreeCAD, kind of concentrating on some processes within the part design workbench that make things easier, but that are a little bit maybe more difficult to understand. So in this video, I'm going to go ahead and create a 10 cube container, 2 rows of 5 you can see there. And in doing so, I'm going to focus on the use of the multi-transform tool in part design. And along the way, we're going to have to look at mapping a sketch to a face to go ahead and to make the individual dividers. So in this particular case, what we're going to do is we're going to go ahead and we're going to create this 10 cube container. Each of these cubes is going to be 5 millimeters by 5 millimeters. Now, you do have to do some math up front, obviously. So in this particular case, if each of these cubes is 5 millimeters, the total length of this inside has to be 5 plus 5 plus 5 plus 5, added the thickness of the dividers. So in this case, we'll make these dividers 1 millimeter, just for simplicity. So essentially, we have to create a rectangle where the inside is basically 25, 26, 27, 28, 29 centimeters long and 5, 6, 11 centimeters wide. And in doing that, we will then start by creating the rectangle, padding the rectangle, hollowing it out, adding the center divider, which is also 1 millimeter, and then using the multi-transform tool to make the individual dividers. Okay, well, let's go ahead and get started then. So we're in the part design workbench, FreeCAD 21 on a Mac, obviously here. So let's go ahead and create a part, create a sketch, make it, of course, on the XY plane. And we're going to go ahead now and create the original rectangular container. For that, it's easiest always, in my opinion, to make a centered rectangle. So I've done that. I'm going to come over here and move to the center, and you can see that I'm marking the coincident there in the center. Make the rectangle, and set the rectangle, like we said, to be 29 millimeters long and 11 millimeters tall. And we have a fully constrained sketch. So we'll close this and we'll go ahead and pad this. And for the sake of this video, we'll go ahead and make it 10 millimeters. Okay, so now we have the outside or the inside dimensions of our container. So what we're going to do now is to create the container by using the thickness parameter. You could also do it another way by using a pocket, but it's easier for this purposes to do it this way. So let's go ahead and do thickness, and we'll make it a millimeter thickness on the outside. Now what of course this means is that this container has 1 millimeter walls throughout. So even though the internal dimension is still 29 millimeters, the outside dimension is 29 plus 1 plus 2, or 31 millimeters. Similarly, we've got 11 millimeters, 12, and 13 millimeters for the width. And we can verify that for those of you that don't know. I'll select 2 edges here, and then go ahead. Oh, I gotta close out of that. Okay, so go ahead, select those edges, measure, and yes, in fact, we have 31. We can select the outside measurement here, the outside measurement here. Also click the tape measure, and we'll see it's 13. Okay. And this, of course, we can clear all of our dimensions. So now we have created the rectangular box that will hold the cubes. Now let's go ahead and put a center divider in. And the best way to do that, at least for our purposes, is to map a sketch to the bottom. And the way we map a sketch to the bottom is we click on the bottom, we create a sketch, and now this sketch is going to be mapped to the bottom. And I'm going to go ahead up here and view section so I can see more clearly what's going on. And I'm going to go ahead and create another centered rectangle, which will be the center divider. Make it coincident to the center, bring it out. Go ahead and, like I said, we'll make the center divider be 1 millimeter. And the length of this, we can just make it the length of the inside dimensions of 29, and it will still create a solid object. But you could make it more than 29. You could make it 30, for example, and it would still be fine. It'll just overlap the sides. Okay, we have a fully constrained sketch. Because it's in green, we'll close it out. Go back to our model, select our sketch, and go ahead and pad the sketch. We'll make it, let's say 9 millimeters, just so we can tell it aside. All right, so now we have basically our rectangular box with a center divider that we now can start partitioning into cubes. So the next step here now is to design what our dividers are going to look like. And of course you can do this any one of a number of ways, but I'll go ahead and do it maybe in a little more distinct way so we can see how that goes. So the first thing we're going to do is we're going to have to make a sketch of our dividers. So to make things, let's go ahead and rename these. Let's rename this to be box. And we don't need to create another part. We could map it to the face, but let's go ahead and create another part, or another body, I should say. Sorry, body. We'll rename this to be the divider. And it's the divider that we're going to use the multi-transform function on to replicate the divider throughout the length of the box. So we've got the divider, and now we want to go ahead and sketch what the divider is going to look like. So let's go ahead and create a sketch. So now we have to ask ourselves what plane we're going to use. In this case, the plane that we're going to use is going to be the YZ plane, because that's the flat surface. So let's go ahead and click on the YZ plane. And now we're looking on the YZ. Let's go ahead and look at and view section so we can see our cross section. And now we can go ahead and sketch what we want our dividers to look like. In this particular case, I'm going to use the polyline tool, which gives me a chance to talk about something with respect to how we use the polyline tool to create more than just a simple rectangular shape. So I'm going to go ahead and start in the coincident center of the two axes, click, bring it over to the side of the box, and notice I've got a straight line constraint, going to come up, straight line constraint, come over, straight line constraint, hit the M until I get my curve that I want. There we go. Bring my curve up till my curve is straight. Bring it over, hit M again to make my straight line. Bring it to the center. Whoops, didn't click. Straight line constraint, click, bring it down, make it coincident to the starting point, and now we have a completed sketch. Now we can go ahead and dimension and constrain the sketch appropriately. So remember, we're at the middle now of there. So in fact, this distance is 5 millimeters, but actually from the inside edge to the center of our divider, it's 5.5 millimeters. So we're going to go ahead, and as we constrain, we'll go ahead and constrain this to be 5.5 millimeters. And let's go ahead and constrain both of the sides of our divider to be equal. So then we'll make them equal. We'll go ahead and constrain the side to be, let's say, I don't know, 7 millimeters tall. Okay. Now, if we want this centered, we know the distance from here to the center point is 5.5. Remember, 5 millimeter cube plus a half. So we go ahead and we can constrain these in such a way that they're equal. So let's go ahead and make that, let's make that 1 millimeter, which means for this to be centered, this has to be 1.5 millimeters. So now this will be centered inside the cube. And now we have a fully constrained sketch. So we're going to go ahead and close. So you can see where the sketch, you can see now where the sketch lives. Now, to use the multi-transform tool, the sketch and its padded object must be tied to an underlying geometry. Has to be tied to the underlying support structure, in this case being the box. How do we do that? How do we tie this freestanding divider to the part that's box? Well, the way you do that is you first select where you want the sketch to be bound. Go to up here, see up here? Map sketch to face. It asks us to select a sketch, which is sketch 2, that's the divider. Select the method to attach the sketch, the plane face, right, which is what we were going to do. We're attaching it to that plane face. Hit OK, and now we see that we've mapped the sketch to the plane face. At this point now, we can take the sketch and we can pad the sketch. And the sketch is going to be 1 millimeter. Now, when we move to multi-transform tool, this is where you have to understand how the multi-transform tool uses its parameters. And I'm going to preempt a little bit here. The multi-transform tool requires that the length that's specified in the multi-transform option is the distance between the midpoint of the first object that's being transformed and the end point, the midpoint of the last object. If you want FreeCAD to do all the math for you, you actually works best to take this and embed it in the wall so it computes the distance accurately. Well, how do we get that back into the wall? Well, basically what you can do is just reverse the sketch. Now the sketch is actually embedded in the thickness. Okay? Can't see it, but it's embedded. We click OK. And like I said, you can't see it all that well, but it is there. Yeah, I can't really see it, but it is there. Trust me on this. So now we're going to use the multi-transform tool to take that divider and make replications across the length of the inside container. How do we do that? We select the pad, which is buried in the wall here. We hit the multi-transform tool here. And we need to go back to show you. It is pad 2. You can rename it to be, oh, I'll just rename it just for the heck of it. I'll rename it to be div, right, for divider. Okay, so now we got the divider, multi-transform tool. Click divide. That's what we want to make a transform on. And now we can see our multi-transformed message box. We want to right click to add a linear pattern. And it's going to ask us now what direction the linear pattern is. In this case, you can see it's along the x-axis. We want to replicate what's buried in here across the x-axis. So we can go ahead, base x-axis. And now we see length and occurrences. Now this is where it's important if we want FreeCAD to do the math. We want, it computes the number of occurrences to include the end object and the beginning object from their midpoints. The midpoint, if this external here is 31, the internal is 29, right? Because that's how we defined it. 29 plus the thickness of the walls. That means the center point to the center point here is 30. So let's go ahead and make the length to be 30 millimeters. Whoops, go back. And now we select occurrences. If there's only 2 occurrences, there's one contained in the body here and one here. We don't see them. But now we want there to be 5 separate cubes. So here we go. 5 separate cubes means, whoops, 6 individual separators. There's actually 6, isn't there? 1 buried here, 1 buried there. But doing this then allows that each of these is even because of how we've defined that internal space. So let's go ahead and click OK. And we can check ourselves. Let's go ahead and look at the top. And let's ask ourselves, well, is in fact the distance between these things what we think they're supposed to be? If so, they should each be 5, correct? So let's pick a side. Pick a side. Sure enough, 5. Pick one. Pick one. It's 5. Pick one. Pick one. Oh, wait a minute. 5 it is. Okay, so we're all good. Whoops. There we go. So let's go back to the top view. So now we have 5 cubes. Now what we want to do is to take these and reflect them across the midpoint. The way we can do that is we can go back to the multi-transform, double click on it. We can add by right-clicking another transformation, add a mirrored transformation across the vertical, the XZ plane. Vertical sketch, but you can do the XZ, it'll be the same. Okay, and now you can see what's happened here. We have our box. So there you go. This is how you can use the multi-transform tool, how to compute the distance between your objects, and how to use simple math to determine how to space your objects. Okay, well, I think that's it. I'm going to go ahead and put up on the screen here kind of what I did here, so you can maybe just have a look. So here's a brief kind of discussion on how we did that you can probably take a screenshot if you need to do that. Okay, well, thanks everybody. Bye.